Bismillahirrahmanirrahim. My name is Muhammad Rahman Farooq and I will be going to present my non-thesis project report, which is basically the slope stability analysis of Tanjeel formations by the Baluchistan Mineral Exploration Company. Its slope stability analysis is one run by both numerical and analytical methods. Firstly, basic rock properties to given strata of rocks and rock mass parameters are also discussed briefly. Moreover, geotechnical design of mines and structure analysis of slopes are also elaborated. Empirical methods like SMR and numerical analysis is phase 2D are design parameters. Rock slope designs and the problematic area of joint concentration is explained. After analysis, solutions to the problems occurring in concerned slopes are deliberated. Along with that, additional parameters of mine structures, integrity, and slope parameters like heights and angles are recommended. Before going to explain and actually analyze the slope, firstly I will introduce some of the terminologies and principles that are directed towards and are used for the stability analysis of different slopes of given problems. Rhyolite and Shanghai belts, including Tanjeel formations, have become impervious after the discovery of porphyry coppers and gold since 40 years. The company, the Baluchistan Mineral Exploration Company, has been given the charge of copper gold mine of these regions. But after analysis of the local area, many geotechnical liabilities were found in areas which needed urgent attentions. One of them was slope stabilization of very areas. Following data were collected by their geotechnical parties. Engineering principles. These play important role in evaluating the engineering problems. These sections of the video contain principles and softwares which are used in interpretations as well as in resolving the whole project. There are generally three principles given for the stability of rock slopes. Firstly, slope failures never occur suddenly and unexpectedly. The primary reasons for failure is one or more forces acting on potentially unhanged rock mass, causing its some portions to be insecure. Secondly, slope failures try to move toward equilibrium state or stabilization. After slope fails, when some sort of instability occurs under the existing conditions. Thus, failure tend to bring the slopes to some sort of equilibrium. And lastly, a slope failure does not occur without any warning. Before the failure starts, particular movements occurs and there is clear enlargement of tension cracks. Following are the software used in these analyses. RockLab softwares, Deep softwares, Wedge and FEM. RockLab softwares is a program which used to collect the rock mass strength parameters by inputting following useful parameters. While Deep is multi-purpose tool which at smaller scales can also be used to draw the grade structure of different planes which represent the various distance planes. Along with that, it has been always a powerful for the stability analysis of slope. Sometimes Deep work with Wedge and unwedged software designed for surface mining as we as underground mining. As we are here concerned with the mining slope of limestone and dolomite in Tanjeel region, therefore we will have to go through these kind of softwares to check out the wedge created by intersection of two planes. A program used to construct the different designs like slopes, excavations, etc. and do analysis on the basis of stresses is known as phase 2D softwares. Following are some useful parameters we use in rock slope design of open pit mine. Cutting height of pits, total amount of productions, pit slope stabilities, bucket capacity of loading machines, capacity of drilling machines, rock properties and geological characteristics of ore reserves, ore reserve parameters, ore diameters and ore grade solutions. For resolving the given problem, I have borrowed mainly the given outlines so that following sections according to guideline level. As there are some lab data present right now, therefore I will assume some data according to certain conditions with respect to some of the calculations for computing the rock mass properties by using RockLab software and internet as well. Following there is a list of tests required. Point load index, conduct and durability load index. There is a list of estimated laboratory properties which is computed from different sources like internet and RockLab software. Additional data required for basic geotechnical design of open pit mines are geological profiles and lithologies, SMR, rock slope mass rating, factor of safety, weathering states, ground waters and slope stability, behavior of grounds under stresses load, characterization of rock mass, desired life and durability. Analysis for stability analysis of slope. This section is discussed in detail. Further explanations will be given in the following results section. Rock mass classification, rock mass rating, RockLab software for limestone and dolomite, Slope stability analysis using DIP. Following is the joint sets plotted on DIP software. From figure, it can be clearly seen that there is an intersection between joint sets which are three in numbers. These cause it to form wedge with it core plotted in figure above and below. As the intersection is below, the slope face, so there is wedge failure. As we can see that there are many stereographic lines, so this case is highly a toppling failure. Another information given by above picture is planes are critical. Therefore, the intersections planes are these joints planes as shown above. Result for analysis of joint sets considerations are as follows. It shows there are major three joint sets E at angle 57.61, 30.81 and 9.04. It can be seen there is no plane failure, rather wedge and toppling failure. After plotting all the joint sets on deep software, problematic areas are identified for wedge failure. From above table, a plane failure is expected at dip direction angle of 60 degree. Or there is high chance of wedge and direct toppling failure at 60 to 330 degree of dip direction. While oblique topplings might occur at 330 to 30 degree. By using dip software, we found two critical joint sets which are intersecting each other just below the slope surface. So we put the dip and dip direction of those joints in the wedge input data as shown. By applying the above input parameter in wedge, we found the following results with a safety factor of 10.6 as shown in the figure. By wedge, we have a steer net showing slope face and the intersection of two joints. Analysis technique for slope mass rating (SMR). Slope mass rating is used to find the stability of slope using the different parameters, and it is used to also to find the appropriate support system. Slope mass ratings will be used here as an impact of toppling failure on slope surface for limestone and dolomite. Slope supports as GSI of rocks is given. So from that I will reduce RMR, and by using RMR is used to find SMR, I can find the type of support needed for slope stability. As SMR is 26 and 31, so from the following figure, it can be seen that that for stabilization of slopes, reinforcements like bolt, anchors and toe protection is required. While in case of dolomite joint sets, stabilization could be achieved by simple scaling. Phase 2D software analysis and stabilization by empirical methods. Keep in view the key design parameters for the stability of your site, and visualizing their effect on the structure enable you to find the slope stability methods. And from above stability analysis, it can be seen that slope is required to flatter at least 57 degree. Other methods according to empirical design, which highly affected and recommended are uses slope stability reinforcement like linear and bolt. Although these are my recommendations, but they highly depend on economics and performance of methods like with time. Result as from the result computed, I have concluded that the wedge failure and toppling is created, but the safety factor for this plane for toppling is low, which means toppling failure going to happen, but these will happen with a warming alarm. Environmental impact. There are various environmental aspects of working site in Tanjeel where these kind of slope in such conditions are running. Due to instability of slope, various kind of accidents are happened commonly. Ground vibrations are reduced when the material is sliding. Dust and noise due to unconventional drill and blast methods. Secondary blasting has also several effect on the atmosphere as the border are formed. So in the end, I conclude that I have analyzed the different site data with the concern of slope stability by plotting the data. A detailed rock slope stability analysis is done using different software like RockLab, Phase 2D, Deep. Thus, I was able to identify different kind of failures in different slopes. Other than that, overall improvement of system was suggested to verify the slope stability. And following are the reference. Thank you so much.